Today we're going to start Unit 6, and Unit 6 is all about solutions. So today is just going to be an introduction to solutions, and we're going to talk about a lot of vocab that you need to know to understand the different parts of the solution. So first, what is considered a solution? A solution is a mixture of substances that is uniform in composition. Well, what does that mean if it is uniform in composition? It means that the different components that make up that solution are not easily distinguished. You can't separate or see the separation between parts of a solution. An example of a solution is salt water. So let's say we had table salt and you put it in water and you stirred it until it dissolved. Once that salt dissolves, it is a solution. You can't see the separation between the salt and the water. It is uniform in composition, it is the same all the way throughout, and the individual components are not easily distinguished. There are two parts that make up a solution. The first being what we call the solute. The solute is the dissolved particles. So using our salt water example, the solute would be the salt. So whatever is being dissolved is the solute. If it's salt water, the salt is being dissolved. If we're making a solution of sodium hydroxide, the sodium hydroxide gets dissolved in water. That would be the solute. Whatever that solid substance is that's being dissolved is the solute. We call the other part of the solution the solvent. Solvent is defined as the dissolving medium in a solution. So the salt would be the solute, the water would be the solvent. The solvent is whatever the solute is being dissolved in. A lot of times it's water, but not always. Another example would be, let's say you wanted to put some sugar in your coffee. So the sugar is being dissolved in the coffee. So sugar would be the solute because it's being dissolved. The coffee would be the solvent because that's what the sugar is being dissolved in. Let's say you wanted to increase that process. Let's talk about ways to speed up dissolving. The first one should be pretty obvious. Think about if you ever put coffee or put sugar in your coffee, or if you ever made lemonade or Kool-Aid from a powder. Once you pour that solid into your liquid, what do? You probably stir it. Stirring is the first way to speed up that dissolving process. What happens is it helps spread the solute evenly throughout the solvent, which makes it have more access to it, quicker access to it is going to speed up the dissolving process. Next, If we want something to dissolve faster, we can increase the temperature. Again, I'm going to use coffee as my example. If you drink iced coffee and you try to put sugar in it, you've probably noticed that the sugar doesn't dissolve very well. But if you put sugar in the hot coffee, it's going to dissolve much quicker. That's why places like Starbucks use a liquid sugar in their iced coffees. What actually happens is the hotter temperature of the solvent actually speeds up the movement of particles. Temperature is a measure of kinetic energy. Kinetic energy is the energy of motion. So if molecules are moving faster, it's going to cause them to dissolve quicker. Lastly, we can increase the surface area. So if you were to put like a sugar cube in your coffee, it would probably take a very long time to dissolve because only those sugar molecules on the outside of the cube are exposed to the coffee to let it dissolve. If you were to break up that sugar cube into small pieces, increasing the surface area, it's going to dissolve much quicker. All right, next term. Concentration. Concentration is just a measure of the amount of solute in a given quantity of solution. So let's say I had 1 liter of solution. The concentration would tell me how much solute I have in that liter of solution. If it is a dilute solution, it means that we have a low amount of solute. If it's not very concentrated, we call it dilute. It has a small amount of solute. So if we're making salt and water, if we just dissolve a very small amount of salt in a liter of water, it's going to be very dilute. The opposite of that would be a concentrated solution. If it is concentrated, it means there is a high amount of solute. If we add a lot of salt to that 1 liter of solution, it is going to be more concentrated. So you should be able to use these terms. So let's look at 2 scenarios and see if you can figure out what happens. What will happen to concentration if, first scenario, we add more solute. Or B, what if we increase the solvent? So take a second and think about both of those scenarios and tell me what will happen to concentration. Will concentration increase or will it decrease? Well, we could see that as we add more solute, it becomes more concentrated. So if more solute is added, concentration increases. Let's say we are making lemonade. The lemonade powder would be your solute, the water would be the solvent. If you continue to add more and more lemonade powder, that concentration is going to come up. It's going to have a higher amount of solute, it's going to be more concentrated. Well, let's say now we add more solvent. Think back to that lemonade example. The solvent would be the water. So if you add more water, that means the concentration is going to go down. It's going to become more diluted. We're going to dilute that solution with water, so concentration would decrease.